All right, good afternoon, good evening, good morning, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this lesson. Happy 2024. Welcome to the new year. This is our first lesson in 2024. So please comment, like, and share and subscribe. Don't forget to subscribe so that our channel can grow. Now, in today's lesson, we are going to show that the equation tangent to this one at this point can be written as this. Okay, so if you remember a few things about tangent lines, so if you have a curve like that, then you have a line tangent to that curve at a certain point. Okay, so let's say we have this equation y is equals to f of x, and this line is tangent to this one at this point. So what we just have to do is we need to find the gradient of y with respect to f. Then we'll put in the coordinates x naught comma y naught, and that gradient we'll find. So in short, we need to find dy dx of this, okay, which will give us a gradient function, and we'll replace these coordinates into this gradient function, and whatever we'll find will be the gradient of this line. And since we have 2 points and a gradient, we can find the equation of this line. So that will be the first step, is finding the equation of this line here. So what we're going to do is very simple. So first of all, we have this line right here, which is y squared is equals to 4x, and we're finding the gradient at this. So we have y, we'll make x subject of a formula here. So we'll say x will be equals to y squared over 4a. Okay, then basically we're going to find dx dy, because we know that this is equal to 1 over dy dx. So dx with respect to y, this will give us 2y over 4a, which will be equal to y over 2a, of which now when we find dy dx, we know that dy dx is equal to 1 over dx dy, which is the inverse of this, which is just 2a over y. Okay, so now this is the gradient of the tangent. Okay, this is the gradient of the tangent. Now we need to replace in the coordinates at the point where the tangent will be. Okay, so this tangent is at x naught comma y naught. So at x naught comma y naught, the gradient m, which is equals to 2a over y, will be equals to 2a over y naught. So this is the gradient of the tangent. Okay, so this will just be simplification otherwise. So again, running through what we're doing, so we have this function that has a tangent at this point. So we need to find the gradient function of this function. So we just differentiate dy dx, or we can find dx dy, and simply knowing that dy dx is the inverse of dx dy, so we can put in the coordinates of the point where the tangent is, and that will give us the gradient of the tangent. Then now from here we can use the equation y minus y naught is equals to m x minus x naught to find the equation of the tangent. So at x, let me use yellow for this one. So at x naught comma y naught, our equation will be y minus our point there, y naught, is equal to, our gradient will be this right here. So that is 2a over y naught. then open brackets x minus x naught. Okay, we've substituted these points here. Now we can simplify. So from here it's just simplification. So we can say this times everything here, it will just be y. Let me continue. Okay, let me say this times this, that will be y times y naught, okay, minus this times this, it will be y naught squared, which will be equal to, and distribute the 2a inside here, so that will be 2a times x, so that will give us x, then minus 2a times x naught, so that will be 2a x naught. Okay, so here what we basically did is simply cross multiplication. So we said this times everything here, and this times what is inside here, so which gave us this. And now here we so knowing that y, we know the equation of y is equals to 4, y squared actually is equals to 4ax. Now at x naught comma y naught, when we replace these two coordinates in here, we'll see that y naught squared, we replace y naught here, will be equals to 4ax naught, like that. Okay, so x replaced with x naught and y. So meaning that where there is y naught squared, here we can replace with this. Then we further simplify. So this now becomes, so I can rewrite this, I'll rewrite this part as y naught minus, this part will be replaced with this, because y naught squared is equals to this. So we say minus 4ax naught is equal to, we have this part here, which is 2ax minus this part here, which is 2ax naught. Okay, then we can transpose this, goes the other side. So we are going to have y naught being equal to 2ax minus, or we'll just say it will be minus 2ax naught plus 4ax naught. And basically here we can say this can be simplified as y naught equal to 2ax, then these will add up to give us plus 2ax naught. Okay, then here we can factor out, which is 2a. So we are going to have y naught equals to 2a outside, x plus x. So this is the equation of the tangent as required, because we were told the tangent should be that, okay, which is this right here. Okay, so just a quick run through of what we were doing here before I conclude. We were asked to show that the equation of the tangent to this line at this point is given by this right here. Okay, so we said to find the tangent of this line at a particular point, we need to find the gradient function first of all. So we need to differentiate this with respect to x. Okay, so after we differentiate with respect to x, we'll find dy dx, and we replace in the coordinates, and we said the x naught comma y naught, we replace in the coordinates. This will give us the gradient, okay, and that gradient is the gradient of the tangent. Okay, then from there we need to use the gradient and the coordinates to find the equation of the tangent, which is supposed to give us this when simplified. So basically that is what we did. And for us, we thought it wise that we find we make x subject of a formula so that we find the x dy and later find the inverse, because x is equals to y squared over 2 over 4a. So we can find the x dy as we did here, and we now find the inverse of this, which is dy dx will be equals to the inverse of the x dy, which gave us 2ay over that. Then from there, that is our gradient. We have our gradient here. We're replacing the coordinates. We need to replace in the coordinates into the gradient function, which gave us this. Then from there, we use the equation of the line to find the equation of the tangent with this gradient, which we replace here, and the coordinates that we have, which is this point and this point. Then we simplify from there. It gave us what we had right down here. Right. So for now, it's have a good evening, and see you in our next lesson. Novim Gordon.